This is the topology that we would like to use to learn practically these two topics, not so stubby area and not so stubby area, totally stubby area. All right, so this is two things. Now what we learned here is we'll have LSA type 7. Let's go see this first. You see, this is the area that I'm going to make it as not so stubby area. We have two ISPs. This is ISP 1. This is ISP 2. Both are advertising the internet to you. This is the internet. So router 6 and all the routers in this area. In our example, we just got 3 routers. In the real world, you may have 10 routers, 20 routers. All the routers are now learning type 5 coming from 2 ABR. This is one ABR and this is another ABR. So this 2 ABR provides these networks. So there are two sources for the internet. First, let us see that one. I'll go to router 3 and add that newly added interface. This interface still not configured. I'm going to configure this. On router 3, see, show IP interface brief. We don't have that F1/0. It's still down and no IP address. Interface F1/0, IP space address 10.200.0.3, 0.0, and we are going to run RIP, router RIP version 2, network 10. That's all. Secondly, what we are going to do is we are going to redistribute the RIP into OSPF. Router RIP. First go to OSPF. Redistribute RIP, including subnets. Hey, wait, one thing I didn't do. Under RIP, I need to say no to somebody. Done. Next is for the return traffic, we need routes on router ISP2. So I'll go to router RIP, redistribute OSPF1, metric, let's say 3. This is just redistribution, same like what we did in router 5. Same like what we did here from RIP to OSPF and OSPF to RIP. I've also done here RIP to OSPF, OSPF to RIP. As a result, if we now go to router 4, show IP route OSPF. Please pay attention. You started learning 7 network from router 3. You see, this guy prefers to go this way, not this way. Let's go and check on router 6. Show IP route OSPF. What's wrong? Okay, OSPF is new. Router 6 is newly added. That is why. Let's go configure. I'm sorry, this is newly added. So let's go to router 4 and configure this interface. Interface F. F00 is newly added, so .46.0.4, then IP OSPF1 area 1000. Correct? Likewise, I go to router 6. You know why I'm configuring loopback first? Because when I enable OSPF, it will pick a router ID. If I have loopback, it will pick from there. Otherwise, it will go and pick from interface physical. Also, I need to configure on R5 F00 with this IP address. R5 this is the one which connects to the router 6. Oh no, maybe 1000. I'm expecting neighbor now. Okay, neighbor has come. Okay, please pay attention. Now the topology is ready. Let's go back and check router 4 routing table. Show IP route OSPF. You see, even now, to reach the internet networks, it is going via router 3. And the cost is the default. Let's go to router 6 and check. Show IP route OSPF. This is also going via the same path, you see, goes to 4. What may be the issue? Is there any issue with router 5? Check the neighbor. Okay, for 10.57, it is going directly out via 5. You see this ending number? That's the gateway, router 5. Whereas for these internet networks, it is going out via 4, which you do not want. Listen. For this network in RIP, router 6 takes this path. Whereas for these networks, it takes only this path. What may be the reason? Let's check. The reason, let's check the database. Show IP OSPF database. You see, I'm learning these networks from router 3, not from router 5. What may be the reason? Let's go and check in 5. Show IP route RIP. Am I learning through RIP? This is the problem. The RIP is not running here. RIP is not running here. Let's go enable RIP. Or RIP may be enabled, but it's not learning. Yeah, RIP is enabled, I can see here. And okay, even the redistribution of OSPF is happening. I can see. And why? I know the reason why. Show IP route. I want you to focus. Only then you can give an answer for my question. These networks, it shows that it goes via 6. Even router 5 is not taking this exit. Even router 5 is taking 6, 4, 3, and ISP2. We want all the routers here to take this path. Now you try answering this question, why router 5 routes are not seen in router 6? Why these networks are not even seen in the routing table of router 5? You see here, router 5, here. Show IP OSPF database. Even the database don't have the redistributed routes. Fix it. No. Stub is not a problem because I see type 4 summary. Let's say. Try answering. It's a very nice answer. If you recall your CCNA, you can answer this. See, in router 5, we are redistributing. I can show you that. Show WAN section router OSPF. I am taking RIP and putting all the RIP routes into OSPF. Same way, we also did the other route. OSPF2, OSPF2, RIP we have done. Now, question is this. Why even router 5 don't learn these networks? We are running RIP here in between. We are running RIP. And this router ISP1, it is advertising this network. What is the proof? I'll show you the proof. ISP1 show IP RIP database. See, RIP is advertising these networks. It is advertising this network. That's why it is there in the database. It is advertising. ரொம்ப correct சொன்னீங்க. So Darshan, did you understand that? Correct. AD value. Okay. So we have even given node summary and RIP version 2. Everything is fine, but we are not learning. The reason is AD. Let us go change the AD. I'm on router 5. I'll go to RIP and set AD. Distance is the command. The default is 120. I'm matching with OSPF. Or let's give lower than OSPF. I'm giving 113. Let's check now. Show IP protocol. You can see RIP has got administrative distance changed. As a result, show IP route. You will see now the routes on router 5. Oh, no, it's still coming from 6. Let's check the database. Show IP OSPF database. Okay, still it shows 3. I changed the distance. I have changed the distance, administrative distance. For testing, what I'm going to do is I'm going to shut down this interface G5/0. I'm shutting down so that router 5 should take this. Wait some time, still the convergence didn't happen. For 10.57, it is taking 5. But why not? Still it is holding this. How come? I go to router 3. Show IP route. We are, it's still learning. I have shut down already the interface. I don't know how it is still. It's simulator. Interface F1/0. I'm shutting down this interface. So I'll go back to ISP2 and bring the interface up because I have shut down on router 3. I've shut down here. Okay. Now, because I have shut down there, ISP2 is down. Show IP route now. Wonderful. Now it shows that for 7, it is going via 4. If it goes via 4, it will go to 6 and then 5. Let's go to 5 now and check. You should see the route now. You see, 5 says exit is this. It's no more via area 0. It is taking direct exit. Even router 6 takes direct exit. You see, direct exit. Okay, right. So when this router 3 comes, let's bring router 3. Okay. When 3 comes, let's see whether it is switching back to ISP2. Go to router 5 and check now. Okay, 6. Okay, 4. Okay, still goes via 6. Cool. And router 3. It goes via 4. Same administrative distance problem here. Okay. Let's go and set administrative distance of RIP here higher. Router RIP distance is 110. No, 110 is OSPF. Let's put 105. I'm going to clear the routing table process. Clear IP route star. And I'm refreshing the routing table so that I can see the latest one. Show IP route. Okay. Now it's going via ISP2. What about router 4? Earlier it was going via ISP1. Now this is also going via ISP2. What about router 6? This is also going via ISP2. What about 5? So back to the default. What do we see? What do we see and what do we want? Well, we see that all the traffic from this area goes through this way. We need to overcome this. Before that, tell me what might be the reason. Try telling me what may be the reason. The reason is this. When router 3 learns and it works, this one, for example, from 2 source, it prefers the one with the directly connected. No, that's not the story here. That's not the story here. This router 3 is using RIP route. That's the mistake I have done. I should go lower than 110, not 130. I mean 103. That's what I was thinking in my mind, but I was typing 113. Okay, problem solved. 103 or 105, whatever. Okay, now let's see. At last we have come to the place where we can test this not so stub area. Show IP route. You see, this has got now the clear IP route star. I'm refreshing the routing table. Great. See, now we got the rip routes. We can start testing now. See, this one may have some impact on router 6. Let's check router 6. Earlier it was going via ISP2. Cool. You got both the routes. This is what actually in the beginning I was searching for. Router 6 is learning type 5 LSA from both ASBR in area 0 and ASBR local area 1000. Same network coming from multiple source. Now it is going to pick a path according to the cost. You see the cost. The cost this way is lower. This cost is lower. So it will go this way. For this, going this way is also same cost. No. For router 4, it may go this way. It's just one cost. So what I'm going to do to poison, I'm going to increase the cost here. Or while redistributing, I'm going to give more cost. What is the default cost? 20. I'm going to say 25 on R5 so that every router will go this way. And then we'll configure NSSA. See, my idea of changing the metric while redistributing on R5, show run section router OSPF. The default metric is 20. I'm going to give more metric so that ISP2 will be preferred. Subnets metric 200. So now automatically show IP OSPF database, you have both, but when you check the routing table, okay, I'm putting OSPF. All right, now this one having a RIP route because it is directly connected to RIP, but when you go and check in R6, though database has got both, routing table prefers to go via ISP2 because it is only 20. Router 4, if you see the picture, router 4 is here. It prefers to go this way. Because when you redistribute, we said 20. We didn't say anything, the default is 20. But here we have say 200. So every router will prefer to go this way. This 200 we added just to simulate. But in the real world, you will get the 200 or something bigger because of the bandwidth, something like that, cost, something like that. So what are you going to do to make these routers to exit this way? NSSA. Are you ready for it now? Right now, router 6, if you check the routing table, gateway is router 4. But after configuring NSSA, this will be N2, N means not so stub area, and this will be router 5. Ready for it? So far good. Are you ready for it? Shall we test? Okay. I'm starting from router 4. Router OSPF 1. Area 1000 is not so stub area. Boom. Should do it on every router. Router 6 also. Router OSPF 1. Area 1000 is NSC. Also do it on router 5. Router OSPF 1. Area 1000 is NSC. Alright. Now what are we going to see? We will see only one exit, and that will be via 5 on every router in 1000 area. Let us go to router 6, which is totally inside area 1000, and check the database. Show IP OSPF database. Listen, you will not see type 4 and 5. You will see type 7. You see? Type 4 is missing. This is type 3, summary lesson. You see type 7. And it is coming from router A, router 5, which is ISP, one side, ASBR. Check the routing table now. Show IP route. You see N2. And remember, we gave metric 200. So here, metric 200, that one is only 20, but that one did not even come. You don't have those routes in the routing table. Sorry, the database. You don't have that link state information. So this router cannot use ISP2. It will use only ISP1. Now let's go to router 5. Show IP route. This one will have directly RIP route, so no worries. Now one more thing is, let's check router 4. See, router 4 is a member of area 0. So it will go via area 0. Let's go check. Router 4 in fact will have two database. It will have two database, one for area 0, another for area 1000. Show IP OSPF database. You see, this is area 0 database, and this is area 1000 router LSA, network LSA. Now area 0 will have type 5. See, this is area 0's type 5. This is area 1000 type 5. See here, it is not mentioned, which means area 0. This is area 1000. Right? Okay. But which one it will follow? It will follow type 5. Show IP route. The reason is this one is also a member of area 0. So you have seen router 6 going via this way. It's because of NSSA. And in router 6, you don't see type 4 and 5. Show IP OSPF database. You see type 1, type 2, type 3, and sorry, on router 6, I should show you. All right, you see type 1, area 1000, type 2, type 3, and type 7. So as we have learned, the external routes are still seen, but not as type 5, as type 7. So that it can prefer the local ASBR instead of going through another area. Did you understand this not so stub area? Okay. Now to make it as totally not so stub area, just go only to router 4 and add additionally one. See, you should configure NSSA on every router in this area, 1000. Don't remove that configuration from router 6 and router 5. Keep that configuration. Additionally, to make it as totally not so stubby area, you go here router OSPF 1. This you configured already. Now, along with that, you say no summary. So the type 3 will also be denied. Okay, type 3 will be denied. Go to router 6 now. I'm in router 6. Earlier this was there. Type 3 was there. Summary LSA. But now type 1, type 2, and type 3 gives you only a default route and type 7. So you don't even see type 3, 4, and 5. You don't even see 3. 3, instead of 3, you get only one default route. So your routing table will be very small. In routing table, you have a default route so that you can ping area 10. This is in area 10. What? Why? Router 1 is not on. It's ping router 2. Yeah. So you're still pinging the other areas, and you are pinging ISP, and you got routes for local, same area networks. Simple. You still have reachability to other areas and also to this one. To this one, you're able to ping this one. Listen carefully. If this ISP1 goes down, what will happen? See, right now your ISP is there, so you're going via router 5. If your ISP goes down, you got a default route to go and ping. You're going to see that now. I'll shut down this one on ISP1, 7776. I'll go to ISP1. Show run 7716, which interface? Loopback 6. I'm going to shut down that. Okay, I have shut down. Now go back to router 6. First, let us trace route to 7777. It goes, why it goes like that? I mistakenly I have shut down different interface. Oh, I shut down loopback 0. You know loopback 0? Loopback 0 is 777. See, you already saw. For 777, it started using ISP2 because ISP1 is not having the route. For this, ISP1 is having the route, so it is going via 5. Understand this carefully. Router 6 goes via 5 for all these networks. But for the network which ISP1 did not give or don't have, it goes via ISP2. How? Because it has got a default route. It has got a default route. You see, 7777 is missing here. All the missing networks, you still have reachability via ISP2. Wonderful, no? So even if you have two ISPs, for those networks which local ISP can give you, local ASBR can give you, it will use that ISP1. For the other networks which ISP1 cannot give, as well as for the other area networks, it will use the default route. This is how you can have different type of special area types according to your policy. So we have seen 4 types. When I configure this area as a stub, 4 and 5 denied. When I configure this as totally stub, 3 is also not allowed. When I configure this area as a not so stub area, 4 and 5 denied. Instead, type 7 comes. And when I configure not so stub area totally stub, then 3 is also not denied, not allowed. 3, 4, 5 is not allowed, and you got only 7 and the default route. Should I repeat? All right, then.